When measuring the association between variables, we often use Pearson or Spearman correlation. But what if the variables being measured are nominal and interval or ratio? That's why we need to understand the Eta correlation coefficient. In this video, I will explain the concept, how, why, and when to use the Eta correlation, and how to calculate it using SPSS. We will also understand how to make this Eta correlation more meaningful in research by the end of this video. Before we dive into the exercise, allow me to explain what, when, why, and how to use Eta coefficient. When measuring correlation, the hypothesis is that the relationship between the two variables is linear. However, sometimes the relationship is not linear, especially when you use nominal and interval or scale variable. Normally, we will use Pearson correlation to measure this kind of association. Well, please don't do that. In this term, using Eta coefficient is more appropriate to measure the relationship of nominal and scale variable. For example, if you want to know if gender could affect the salary of worker, the Eta coefficient can measure how strong that relationship is. Eta coefficient is also called correlation ratio. We use Eta coefficient when one variable is nominal, like categories or groups, and the other variables is interval or scales. This is the numbers that can be measured like height, income, salary, and so on. And how to measure the Eta coefficient? Well, Eta correlation is measured based on the sum of square concept that we use in analysis of variance or ANOVA. The square of the correlation ratio, known as Eta squared, is calculated by dividing the between group of sum of squares by the total sum of squares. This ratio provides a clear picture of the extent of linearity or non-linearity among the variables. To obtain the Eta, we just need to use the square root of the Eta squared value. After that, you can interpret the Eta value based on this classification. 0 to 0.2, very weak or no association at all if it reaches 0, 0.21 to 0.4, weak association, 0.41 to 0.6, moderate association, 0.61 to 0.8, strong association, 0.81 to 1, very strong association, or if it reaches 1, it is perfect association. And you can also obtain the coefficient of determination or R square, or in this case we used to call it Eta squared by squaring the Eta value. The Eta square shows the proportion of the variance in scale variable that could be explained by the nominal variable. I'll explain it in detail when we do the exercise in SPSS. Next, let's get practical. In this example, I have 30 cases of the monthly salary of the workers based on the gender. You can see at the variable view, 1 for female and 0 for male for the gender variable. And the measurement level for gender is nominal, and for the monthly salary, the measurement is scale. Please put the right measurement. Okay, and before we do the calculation of the Eta correlation value, let's see the overview of this variable by using the scatter plot. Okay, go to Graphs and then click Chart Builder. Okay, let's click OK. Click Reset here, and then let's click Scatter Dot here. Move the simple scatter dot into the preview area. Click the gender, move to the x-axis row, and then for the monthly salary, move it into the y-axis like this. Okay, then just click OK. And in general, you can see that the female monthly salary is really high, higher than male. Okay, but we need to prove it, the association between the male and female salary by using the Eta correlation. But in general, by using scatter plot, you can see that female salary is higher. And to measure the Eta correlation coefficient, go to Analyze, Descriptive Statistics, and then select Cross Tabs here. Okay, let's put the monthly salary for the column and the gender for the row. Okay, and then don't forget to click the Statistics tab here, and then check the Eta options here by the Nominal by Interval tab. Don't forget to check it because this is the option that will show the Eta correlation value. Click Continue. After that, click OK. Well, you have three output tables in the cross tabs: the case processing summary, the cross tabulation itself, and also the directional measures. Let's go directly into the third output. At the directional measures output, we have two rows that shows value. The first one is the gender dependent that has 1 as the value. You can just ignore this output because it shows nothing or it has no meaning at all. And the next row is monthly salary dependent. You need to pay attention to this row. The value is 0.88, which means that there is a very high or very strong association or correlation between the nominal and the scale variable, or there is a very high or very strong association of correlation between the gender and the monthly salary. You can see the classification of the interpretation based on my explanation at the beginning of the video. The next question is how far this nominal variable could explain the variance in the scale variable, or how far this gender variable could explain the variance in the monthly salary variable. Well, to do this or to measure this, you can use the Eta Squared value, or you can use the coefficient or determination. It's the same thing in the Eta Coefficient. Okay, to do this, you just need to square this Eta Coefficient value. I'll show you in manual. 0.88, and then you just need to square the value. Okay, remember the value is 0.7744, which means that about 77.44% the variance of the monthly salary could be explained by the gender. The rest is explained by another variable. And is this the right thing? Yes, you can use this kind of analysis to improve or to add another insight to your analysis. The last question that we might want to discuss is that does the nominal variable, or in this case the gender variable, statistically have a significant difference to the ratio variable or to the monthly salary variable? Well, I have not found any literature that shows whether we can do a hypothesis test on the Eta coefficient like in the Pearson correlation. However, there is one interesting article that I found that we can see a significant difference between the nominal and scale variables for the Eta coefficient from the p-value that is generated from the sum squares of between in the analysis of variance or ANOVA. Also, I will show you the evidence that the Eta coefficient can be easily obtained through the analysis of variance. So let's perform the analysis of variance first. Go to Analyze, Compare Means, and then select one, Weigh ANOVA. Okay, and then move the monthly salary to the dependent list box here, and then the gender to the factor box, and then click OK. You can see we have ANOVA output in the output window, and at the sum of squares between groups we have this value. Okay, this is the p-value that we need to pay attention, and the significance value or the p-value is 0.00. If the alpha is 5% or 0.05, we can conclude that we reject the null hypothesis. We can infer that there is a significant difference for monthly salary based on the gender. Okay, and it could be explained by the Eta correlation value here, and also by the scatter plot that we made before. And let's see the sum of squares between groups and the total. Let's divide the sum of squares between group and the sum of squares total. Okay, let's double click it. I'll just copy this value to the calculator here, and then divide it with the sum of squares total, like this. Okay, and then you can see if we divide the sum of squares between group to the total, we have the Eta squared, or the coefficient of determination value. It's the same value that we obtain if we square the monthly salary dependent row here, or we square this monthly salary dependent. And if we square root this value, this 0.7742, let's square root this, just click it. We have the same exact value that is produced by the Eta correlation procedure that I showed before, okay? 0.879 and so on, or if we use 3 decimal, 0.870 and so on. Okay, now you fully understand how to use Eta correlation, how to use the Eta square, and how to obtain the conclusion whether these nominal and scale variables is statistically different or not. Well, see you in the next video.